is we have learned the methods to solve pair of linear equation in two variables, right? Now everybody knows how to solve it using graphical method. Also, we can draw the graph and find out what is the solution of the pair of linear equations. If not, if we don't want to draw the graph, we can algebraically also solve either using elimination method or substitution method. So now what we are going to do, we are going to use that knowledge and we are going to solve some real life problems. So we're going to start with the very simple one, which is there in the beginning of your NCERT book, this problem. So there is this girl, Akhila, who went to her village fair and she wants to enjoy a giant wheel and she wants to play hoopla. There are two things which she wants to do in the fair. And the thing is, she has got only 20 rupees to spend. So her budget is fixed. So she decided in a certain way, she decided that she will play a certain number of times on giant wheel, and she will play this hoopla game also some certain number of times. So we have to find out how many times she played the giant wheel and how many times she went on whatever she played hoopla. Okay, it's a very important, very powerful thing. Pair of linear equation in two variables can help you solve some real problems. Everyone understands the story, what is happening? Akhila is going to the fair. There are two things which she can do. She can go on a giant wheel, right? And she can play hoopla. Now, how many times she did both of them? That is what we need to find out. Okay. So in this situation, in the story, they are saying that the number of times she played hoopla is half the number of times she went on the giant wheel ride. So can I say that let the number of times she went on giant wheel ride be X? That's what I have done. So let the number of times she went on giant wheel, let it be X. Now, what is the number of times she went on hoopla then? She played hoopla.
Y.
Yes, since this is a pair of linear equation in two different variables, so I have a luxury. I can call one of the variables as X and other one as Y. I don't have to do any straight away. I don't have to go into calculations right now. Okay. If we wanted to solve this problem using a single variable, that can also be done. Okay, it can be done. I think you people have done that before also. Problems like these where there are two variables needed, but still we can solve them using a single variable. But anyway, here we have the luxury. We can call them one of them as X, other one as Y. Now let's see what is the relation between X and Y that is given. What are they saying? Number of times she played hoopla. What is that? How many times she played hoopla? Y. So this Y is what? Half the number of times. Half of what? Number of times she went on the giant wheel. So is half of X. Does it make sense? Tell me. Number of times she played hoopla is half of the number of times she went on giant wheel. The story has got converted into a mathematical problem now. Y is equal to half of X. Everyone understands that? Quickly confirm. Give me a yes or no.
Yes, sir.
Yes, sir.
All right. So let's call this as the first equation. And you know, if we wanted, I could have sent the 2 to the other side and 2y is equal to X. And I could have also written as X minus 2y is equal to 0. This is a normal standard form for a linear equation in two variable. I could have done that. But since you have already solved the substitution method, you know that if we had a situation like that, we would have either we are solving this by substitution method or even by graphical method. We have to find the value of y by putting X, no? So no need to do that conversion. We can keep it like this itself. Y is equal to half of X. Okay. Now let's find out the other information what is given, and based on that we need one more equation. Correct? So if each ride costs ₹3 and the game of hoopla costs ₹4. So now they have given the cost. So each giant wheel ride costs ₹3. How many times she went on the giant wheel ride? X times. So how much money she spent on giant wheel?
3 times of X.
Yes. So total money spent will be equal to what? Money spent on giant wheel plus the money spent on Hoopla. So we already know that she has spent a total of 20 rupees, as you can see, provided that she spent rupees 20. So I know that the total money spent is 20. So this 20 is equal to money spent on the giant wheel. So each ride costs 3 rupees and she has gone X number of times. So it will be 3 times of X, right? 3X is the money she spent on giant wheel. Same way, Hoopla, how much does it cost? 4 rupees. The game of Hoopla costs 4. She has played Y number of times. So it will be 4 into Y. So now we have got our second equation, that is 3x plus 4y is equal to 20. Okay. Now we need to solve this problem. Which method should be used?
Substitution.
Substitution.
Yes, we can use substitution method. Do that, all of you. Use substitution method and find out the value of x and y. Tell me. So 3x will be as it is.
What the value, sir?
Okay. Tell me, what is the x value you got?
4, sir.
Total
Y?
2, sir.
2, sir.
4 and 2. That's good. Let's see what I get. Am I doing right? As of now, y is equal to half of x. So that's what I have replaced. Y in place of y, I have written half of x. So this will become what? 2 ones are, 2 twos are. You get cancelled. So this is 3x and this is 2 times of x is equal to 20. So 5x is equal to 20. So I can find that x is equal to 4. 20 by 5, which is nothing but 4. Now we know x, we can find y very easily because y is equal to half of x from the first equation. So y is equal to 2. Now I want you people to think a little bit and come up with some example where you will actually solve this as some real life problem. Can you people take a minute and think about it? Can you think of a situation where we might use this pair of linear equations?
Sir, to compare the age of both two people.
Okay, a little bit more detail. How would you do that? Comparing age means what do you want to do actually? I think we can do that. Go ahead, think about it a little more. And I also want you people to think about some real problem which you would solve. Not some theoretical problem, hypothetical problem, some real problem which you think it will be really useful to solve something interesting. Try to think about it. Take a minute.
So for a population of a town,
Okay, a little bit more detail.
like males, like number of males, number of females, and number of children, like that.
Okay. So since we are talking about 2 variables, so let's forget about the children right now. Let's have male and female. So there are X number of males, Y number of females. And based on that, you want to find the population. Something
Yes,
like that?
sir. Yes, sir.
Okay. Anything else anyone can think? Think along the same line, like this fair situation. The girl wanted to enjoy 2 things. She had a fixed amount of money, only 20 rupees. And then she had to decide how many times to go on each one of them. And there was one more constraint, one more restriction, that she went on the ride of Hoopla half the number of times she went on giant wheel.
Sir, for calculating a profit for a company.
Okay, profit. Yes, it could be. We can have a situation where we have profit coming from two different places. There are some variables X and Y. Let's say a company runs two different operations, like two different projects. Okay, and the number of people working on them. So X number of people work on the first project, Y number of people work on the second project. So how much money the company has to pay to these people working on the first project? Let's say project one has X number of people, and every person gets, let's say, 20,000 rupees per month. And there is another project Y, or project two, I mean to say, where there are Y number of people and everybody gets 25,000 rupees per month. And they have a fixed number of, the total budget is fixed, let's say, like 5 lakh rupees. The owner of the company has only 5 lakh rupees and he wants to invest this money into these two projects. So now he needs to decide how many people to hire for the first project and how many people to hire for the second project. So he can make a decision using this logic. He knows that for the first project, everybody who comes for the first project, because of the nature of the work, first project has some other work, second project has some different kind of work. So let's say the cost is fixed. Very simple situation. In reality, the situation will be very complex. It cannot be just done with two variables, but for a simple situation like we can imagine like this. Yeah. Okay. Everyone understand that? Were you people able to understand this analogy, the story?
Yes, sir.
Yes, sir.
Okay. So I might give you one. Let me give you one more example. Let's say I have two different machines. There is a company, there's a factory, and there are two different types of machines. Let's say there is a machine A and there is a machine B. Okay, and the owner of the company or the project manager, he needs to decide how many hours to run the first machine, let's say X hours, and how many hours to run the second machine, Y hours. What is the total? There will be some constraints, right? There is a possibility that machine A can run only 7 hours or 8 hours a day, let's say, or maybe let's keep it a little more. Let's say a machine A can run up to a maximum of 36 hours at one stretch, and then it has to be left to cool down. Then there is machine B, which can run 24 hours at a time, and it has to be allowed to cool down. Machine A is more advanced. It can run 36 hours continuously. But so you might think, okay, if machine A is more advanced, why not run this always? Why? Let's shut down the machine B. Let's always run this because it can run more number of times, right? You might think like that. But that's not how really things work, okay? So if there is a machine A, it runs more number of times. So it may have some other constraints, like machine A is more costly to run, but machine B is very cheaper. It can run at a lower cost. So we need to strike a balance between these two. How many hours to run for the first machine? How many hours to run for the second machine? So these kind of real problems, you don't have to solve it right now. Don't get bogged down by this if this example is a little too much for you. But just try to understand that what these kind of real problems can be solved using linear equations like these. So here right now you are seeing only simple linear equations in just two variables, and you are seeing only pair of them. But in real life, in some factories, even today, people would have used equations like these and they would have solved some real problem today. But there will be more equations and more variables. It will be an extension of the same idea. So these are not just for your theory, and this is not for your just for your maths book to remember. Some real problems can be solved using these logics. Okay, fine. So let's move on. So in this problem, example one, they have solved the same problem graphically. Everyone has graph paper with you right now? Can you people use graphical method to verify the solution?
Yes.
Okay, so do that guys then quickly. use the graphical method. We will just solve this one problem today. In the next 10 minutes or whatever we have.
Sir, we have to do it in graph, no?
Yes, we have to do this on a graph paper now. The same problem what we had just now. The example one, this is basically the same problem which we just solved using substitution method. But I want you to solve using graphical method. So the equations I'm writing directly, y is equal to half of x, and what was the other equation? Three x plus 4y is equal to 20. For the first equation, y is equal to half of x. Let me draw the table x and y value, which is half of x. So I'll find only two values. Let's say when x is equal to
0,
0, what will be the y value?
0.
Yes, good, because when we put x equal to 0, y also becomes 0. Then what else? What should I put x value now?
1,
See, if I put 1, then y will be 1 by 2, no? So I said avoid decimal and fractions. Try to keep some number. So I can keep 2 also, then it will become 2 by 2, which is 1. Let's say I keep x is equal to 6. So y becomes 3. So I'm ready with the first graph. I have got the 2 points. I can plot it on the graph. So the first equation is ready. But I'm going to make the table for the second one also right away. So x value, and in the second equation, what will be y? It will be 20 minus 3x by 4. Everyone did that? So tell me what values can I take here? I can take x equal to 0. That will help. That will make it 20 by 4. It will become 5. So 0 is a good number. Let's take that x equal to 0. If I do that, it will be 20 by 4, which is 5. Then what else? What else can I do? If I take x equal to 1, it will answer y will be fraction. So 1 is not a good number. If I take x equal to 2, still not a good number. 3, no.
Sir, x is equal to 4, sir.
Sir, x is equal to
Yes, if I take x equal to 4, I will get y is equal to some other number. Let's do that. So let's say x equal to 4, so it will be 8 by 4, that is 2. But again, 4 and 2, this is an answer. I don't want to take that right away. You can do that, okay? Don't worry. You can take 4 and 2 also. But for this example, I just want to take some other number. Let's say I want to take what else? I will take 8. So if I take x is equal to 8, what is the y value? Tell me, guys.
1.
Yes, 8 3s are 24, but there is a minus now. 24 becomes bigger, so it will be minus 24 by 4, minus of 4 by 4, it become minus 1, no? Everyone agrees? 8 comma minus 1?
Yes.
Okay, now when you are plotting the graph, okay, so that's my graph ready. Plotting the first one, 0 comma 0. So 0 comma 0, it will be at the origin, of course. This is 0 comma 0, first point. That is the 6 comma 3, 6 here, then 1, 2, 3. 6 comma 3. This is 0, comma 0. So if I join these two using a scale, that will be the graph of the first equation. Okay. Now the other one, 0, comma 5. Where is 0, comma 5? Is this 0, comma 5?
No, sir.
No, sir.
What is this point then?
5,
5, 0.
Yes, this is 5, comma 0. Remember, the x coordinate is 5 here. We want 0, comma 5. So x coordinate should be 0, means it will be on the y axis. And how much above or below? It will be 5 units below, because 5 is positive. So we'll go 0, comma 5 here. Then what else? 8, comma minus 1. Where is 8, comma minus 1? 8 is here. You need to go minus 1 down. So this is 8, comma minus 1. Everyone agrees with me? Am I right? Or did I make a mistake? Now, just take a scale and join these 2 points. So of course, by hand, it's not easy to draw. You people will have a scale and you will draw it properly. So that's your line. So this green line, what is the equation of the green line? X plus 4y is equal to 20. And the red one? Y is equal to half of x, which you can also write it if you want. You can write x minus 2y is equal to 0. So we have to go draw that away. Just write the names. When you plot this graph, always make sure that alongside the line you will write the equation of the line also. Like I have done here, you can see this red line is x minus 2y is equal to 0, and green one. So the equation, what is that? 3x plus 4y. Now, what is the solution over here? Very simple. Wherever the two lines meet. And what is that point? This is the one. So basically, that is the solution of your two equations in two variable. What is the coordinate of this solution, guys? What is the point?
4, 2, sir.
Yes. So even though my graph is bad, but still here somehow we have managed to get 4, 2 as a solution. But on your graph paper, it will be exactly on 4, 2. Tell me if everyone got it exactly. Did the line intersect exactly at 4, 2 for all of you?
Yes, sir.
Yes, sir.
Okay, that means your graph skills are good. Okay, so fine then. So the remaining problems from the exercise. Let's see, we have more examples. Okay, there is example 2, 3, and then these 3 questions. So these are this is your homework. Example 2, 3, and the 3 questions from the exercise. You will try to do this in your home. Even though the question says only represent them graphically, you will also find out the solution and write it down, okay?